Hello friends, this video on aldehyde ketones carboxylic acid part 21 is brought to you by examfear.com. No more fear from exam. Let's take a few more examples. Again, almost similar mechanism. We have to give the product. So here also H plus, and I have this COH here actually. This is same, but just I wanted to use this place for reaction mechanism. So this will go like this. Negative charge will attack this H plus, it will get positive charge, right? This positive charge, this nitrogen will attack this guy. So what you get is RCH double bond C H C. Here I'll get OH, right? There is the H here, and this I'll get NH2, and here I get C double bond O. NH NH2. This is what you get. Correct. Now since nitrogen has given the electron to carbon, it gets positive charge. Nitrogen doesn't like positive charge, so it asks hydrogen to leave, and this hydrogen will go to this oxygen. Oxygen has the lone pair. This will become H2O plus, and the water will go up, and this will become a positive charge. We have seen this mechanism so many times, so I'll just write it here. So this becomes positive charge, H2 will go off, right? So with this it will become, there's the H here, and this is N, this is a double bond here. No. That's all. This is H, this is C double bond O, NH, NH, H. This is what you get here. Correct. Now, if this hydrogen leaves, it will form a double bond. That is pretty good. So it will ask this hydrogen to leave. Nitrogen gets a negative charge, negative and positive charge forms a bond, and you get this double bond here. This becomes R, C. This is H actually here. R, C, H, double bond C, then H, then C, then H, and there is a double bond now between nitrogen and carbon, and this hydrogen is gone. Then I have this hydrogen is gone, right? Then I have COO, NH, NH2. This is what I'll get. And please note that this is one of the product. The reaction can happen also in one more direction. See, in this case, I have reacted this nitrogen with this carbon. This nitrogen can also react. Both are equally potential, right? This nitrogen can also react. So in this case, we will get different product. So it will get flipped actually. So you will get product something like this. CH, CH, double bond N. Now you'll get NH here first, and then CO and NH2, right? So see, it is like this. You are taking this oxygen and this hydrogen, removing water and forming double bond, that is one. Or you are taking this oxygen or this oxygen and this hydrogen and forming double bond. So both are possible output. There are two possible output for this reaction. So we are done with this reaction. Let's try for this reaction. So here also you see I have NH2 and I have double bond H plus. Same reaction. This gets minus charge, slightly positive charge. This oxygen with the minus charge attack this H plus. Nitrogen with the lone pair will attack this carbon. So with this, the output you will get is, I'll draw somewhere here to get more space. So with this you get is C, you get H here, OH, here is CH3 by default, and in this I get NH2 and CH2 and CH3, the C2H5. This is what I get. And nitrogen with the positive charge, nitrogen won't like positive charge, it'll ask hydrogen to leave. This hydrogen will again go and attack this oxygen. This will become H2O plus, and H2O plus will leave, and this carbon will get a positive charge. This is what I'll get now. Similar to what we have done. Correct. Now this carbon want to get rid of positive charge. So how it can do, it can either kick off this hydrogen or this hydrogen. So it will kick off this hydrogen, form double bond with CN, and with that it will form nitrogen will get negative charge, negative and positive will form a bond, so it will get this product. This is the product, C2H5. Correct. Let's see some more numericals. We have to predict the product form when cyclohexane carbonaldehyde reacts with the following reagents. The first is it reacts with the Grignard reagent, pH, MgBr, and then hydrolysis. And the second is Tollens reagent. So let's start this. What is cyclohexane carbonaldehyde? Cyclohexane carbonaldehyde is something like this. This is my cyclohexane carbonaldehyde. Let's start the first one, pH, MgBr, and then H3O plus. So I have this on in this. If I have pH, MgBr, so this whole thing gets a negative charge, and this whole thing gets a positive charge. That's how it is. And this gets slightly negative, and this gets slightly positive. So this guy, this phenyl, will react or attack this carbon. Correct? And this O minus will attack this MgBr. So with this, the output we'll be getting is this. See? I have O minus, so it becomes O, MgBr, and here I'll get a phenyl group. And there was a hydrogen already there. This is what I'll get. Correct? Now when I do hydrolysis, what will happen is this bond will break actually. This bond will break, and this guy will take this H plus, this bond will break, and this guy will get a negative charge, positive charge, so it will react with OH to form MgBrOH, and this will form OH, EH, and when you give this OH minus, this will react, or this will react with MgBr, give MgBrOH. So this is the output I'll get actually. This is cyclohexyl phenyl carbionol, because it's alcohol. Cyclohexyl phenyl carbionol. Let's see the other reagent. This is Tollens reagent. So we know that Tollens reagent reacts with aromatic aldehydes, right? Anyway, this is not aromatic aldehyde. So I have this aldehyde. The moment I react with Tollens reagent, it will give silver, and it will oxidize this to acid, right? So I can just write this, or let me write this. I have this 2Ag NH32 with a plus sign, and this happens in the basic medium, right? What you get is this, no ring here, CO minus plus silver comes out, there two silver comes out, and NH3 gas, 2 4 NH3 gas, it goes off, and you get some water molecule back. So this is called cyclohexane carboxylate ion. This is what you get when my cyclohexane carbonaldehyde reacts with toluene reagent. Correct? Toluene reagent is a mild oxidizing agent and it can easily oxidize aldehydes to carboxylic acid, and that's what it is doing here. So we have seen these reactions. We have to see cyclohexane carbonaldehyde. This is my cyclohexane carbonaldehyde, and this reacts with semicarbazide. Semicarbazide, you should know, is this compound. This is semicarbazide. Again, here also it reacts as mild acidic medium. So if you see this is a lone pair, what will happen is here this will go to this carbon and this oxygen will try to get this H plus, right? So what we'll get output here is, I'm writing in the next line, this will become COH, this is H, this is NH2, this is NH, this is COO, NH2. Now if you see, nitrogen gets a positive charge because nitrogen has given electron to oxygen, doesn't like it, goes off, hydrogen comes out, hydrogen is now attracted to this H2OH lone pair, this becomes H2O plus, H2O plus comes out because the heavy molecule, carbon gets a positive charge, so this is what you get. Carbon with a positive charge, nitrogen with a hydrogen, CONH2. Now carbon wants to get rid of positive charge, so if it convinces nitrogen to kick this hydrogen out, nitrogen gets a negative charge, negative and positive form a double bond is more stable, so the reaction goes always in the direction for stability, so this hydrogen will go off and nitrogen gets negative charge, negative and positive will form a bond, so what it will form is double bond here. This is the output. This is cyclohexane carbonaldehyde semicarbazone. This is the output. You have to again predict the output when these two reacts with cyclohexene carbonaldehyde. Let's take the first one, the zinc amalgam and dilute HCl. This is pretty easy. I have COH, they react with zinc amalgam and HCl. I have shown you that with this zinc plates, what happens is it gets H plus, right? See, the first thing will happen is it will go in this way, it will get H plus and with positive charge here, right? And then zinc will provide 1 electrons to it. So if you keep doing that, it will become alkane. So end of the day, it will become CH3. So you want to see the reaction mechanism, watch my video in the same series where we have discussed the mechanism, how zinc helps to reduce aldehydes to alkanes. So this is methyl cyclohexane. Let's see this reaction. We have excess ethanol and acid. So I have this again, cyclohexane carbonaldehyde, and react with ethanol. The first thing with acid, some acid is also there. So what happens is acid, this gets negative charge, attracts to this H plus, and this positive charge will attract this carbon. So what will happen here is, because it has lone pair actually, correct? So this becomes COH, H, C, and C2H5, and H. Since oxygen has given electron, it's a positive charge. It doesn't want a positive charge on it because it's electronegative element. It will ask hydrogen to kick off. Hydrogen will go off, and this will become something like this. COH, O, C2H5, and this is H. This is called hemiacetal. This is called hemiacetal. But now it is told that it is excess of C2H5, right? So you're going to use more C2H5OH. So in this case, what will happen is, again, similar reaction will happen and this will go off. Why? See, the first thing will happen is H plus will come and this will attack this H plus. This will become H2O plus. H2O plus will go off. It will become C plus carbon, right? That I think they understand properly. This oxygen will attack this H plus. This will become H2O plus. H2O will come out and this carbon will get a positive charge. I already have OC2H5 and H here. Now the C2H5OH, this will attack this carbon. With this, what you get is this. There's the H, OC2H5 already there, and on this I get OH C2H5. And now since oxygen has given electron to this carbon, oxygen develops positive charge. Oxygen is electronegative element, it won't be happy with the positive charge. It allows this hydrogen to kick off, hydrogen goes off, and what it gets is this compound, and that is my answer. This is my output, and this is the answer. So if you have excess ethanol, you will get acetal, and this is acetal. This was hemiacetal, and you get acetal if you have excess alcohol. This question is pretty simple. Which of the following will go aldol condensation and which one will go Cannizzaro reaction? We know that for aldol condensation, alpha hydrogen is required. If you don't have alpha hydrogen, it goes for Cannizzaro reaction. So methanol. So if you draw the methanol, does it have alpha hydrogen? No, there is no alpha carbon itself. So how it will have alpha hydrogen? So it will go for Cannizzaro reaction. Next is 2-methyl pentanol. So let me draw this meth, eth, pro, but, pent, anal, and at 1,2 position I have a methyl. So this has hydrogen here. So it has alpha hydrogen and this is alpha hydrogen. Since it has alpha hydrogen, it will go for aldol condensation. Next is benzaldehyde. Benzaldehyde we all know. This is my benzaldehyde. And there is alpha hydrogen here. Is it there? No, there is no alpha hydrogen. There is no hydrogen here. If we draw, let me draw it clearly for you. See, if you see, this carbon is not having any alpha hydrogen. This is alpha carbon. There is no alpha hydrogen. Already 4 bonds are gone. 1, 2, 3, 4. So there is no alpha hydrogen in benzaldehyde. So it will go for Cannizzaro reaction. Similarly, for these three, we have to say which one goes for aldol, means alpha hydrogen, and which one goes for Cannizzaro, that means without alpha hydrogen. Benzophenone, similar to benzaldehyde, this will also not have alpha hydrogen. Correct? There is no alpha hydrogen here. So it will go for Cannizzaro reaction. Same thing, cyclohexanone. Let's see this. This is my carbon here. This carbon has 2 alpha hydrogen actually. And this also has alpha hydrogen. So it has plenty of alpha hydrogen. It will go for aldol condensation. A means aldol condensation. The next is phenylpropanone. Let me take a phenyl. Let me take a propanone. One side is phenyl, meth, propanone. Yeah, this is phenylpropanone. So this has alpha hydrogen. Yes, it has alpha hydrogens. Since it has alpha hydrogen, it will go for aldol condensation. Pretty easy. Just find if it has alpha hydrogen, it will go for aldol condensation. If it doesn't have, it won't go for aldol condensation. Next is phenylacetaldehyde. My phenylacetaldehyde. Alpha hydrogen? Yes. Correct? So it will go for aldol condensation. The next is butanol. 1, 2, 3, 4. Alcohol. Alcohol will not go for aldol condensation. It will not go for Cannizzaro reaction also. Why? Because alcohol, only aldehydes and ketones go for aldol condensation or Cannizzaro reaction. Correct. The next is dimethyl butanol. 2,2-dimethyl butanol. Meth, pro, but is my butanol. This is my butanol. 1, 2, 3, 4. At 2 I have 2-dimethyl. Yes. Now this is my alpha carbon, but it doesn't have alpha hydrogen. Since it doesn't have any alpha hydrogen, it will go for Cannizzaro reaction. This will not go for any reaction. Correct. So you can just find easily. If it is aldehyde ketone and has alpha hydrogen, it will go for aldol condensation. Else it will go for Cannizzaro reaction. If it is not aldehyde ketone, it will not go even for aldol or Cannizzaro reaction. This one is pretty important. Please note, this was an alcohol, and the alcohol will go for neither aldol condensation nor for Cannizzaro reaction. Thank you. Visit our website examfear.com to watch more and more quality education videos. You can also attempt free online tests that are there in our website. You can also get access to tons of free study materials, and you can also find free tutors and mentors in this website. Thanks a lot for watching.